Okay, so let's look at this question, which is saying a rule of length 0.3 meters is pivoted at its center. Equal forces of magnitude 4.0 newtons are applied to the ends of the ruler, creating a couple as shown below. What is the magnitude of the torque of the couple on the ruler when it is at the position shown? What is the magnitude of the torque of the couple of the ruler when it is at the position shown? Okay, so this is a couple where we're having two parallel forces, one acting in this direction, whilst we have this other one acting in that particular direction. So this is a couple, which means that the two forces that we have are, of course, acting in opposite directions. Two equal but opposite forces, which means they have the same magnitude, but they're acting in the opposite directions. One on the left, one on the right, parallel to each other. So when you have such an orientation of forces, you're going to notice that it is only going to cause rotation only. When you have such an orientation of forces, it is only going to cause rotation and not any net force. So the turning effect is going to be measured by what? By moment of the couple. So we're going to say moment of the couple, which is similar as torque, will be equal to force multiplied by what? Multiplied by distance, like that, of which this distance that we're talking about, when we're talking about a couple, it is the perpendicular distance. I'll just write it here. Perpendicular distance between two lines. Between two lines of action. Between two lines of action. Like that, which means between that line and that line, the vertical distance, the perpendicular distance between these two is the distance that we're going to put there. Whilst F, of course, is just the magnitude of one force, since the two forces are similar and just opposite in direction. So we've been given to say the length of the ruler is 0.3 meters, like that, which is pivoted at the center. So if you look at this ruler, it is not giving us the perpendicular distance between the two forces that are acting on this particular ruler. So what are we going to do? We are supposed to calculate the distance, which is the perpendicular distance in this case between the two forces or the two lines of action. So I'll just draw a simple diagram just to illustrate the line of action. Okay, I'll say from there up to that particular point, passing through the center. That is the perpendicular distance. So how are we going to calculate this perpendicular distance? This is very simple because we've already been given the angles at which the two forces are acting on. So from the ruler, we have 30 degrees between this force and the ruler. Even this side, we also have 30 degrees. So we can just basically use SOHCAHTOA, since we know to say this is 0.3. That means if I divide this by 2, I'm going to get what? I'm going to get 0.15 meters, like that, which means from that particular point up to that one end there, I have 0. I have 0.15 meters, like this. So we can just basically use SOHCAHTOA. Since there we have 30 degrees, like that, we can say 30 sine 0.15, it is going to give us this vertical distance here. Let's say which this is going to apply even on the down part there. So we're going to have this distance there as 0.15 sine 30, even that distance as 0.15 sine 30. So in simple terms, that means we can just say our vertical distance S is equal to what? Is equal to length that we have sine 30, because we're just basically adding these two values that we have here. So I'll say my distance, or my vertical distance between the lines of action, will be equal to 0.3 sine 30 degrees like that, which is going to give me a value which is equal to 0.15 meters. 0.15 meters. This is my vertical distance. So now what am I going to do? I'm going to introduce my formula back to say my torque will be equal to what? Will be equal to the force multiplied by the perpendicular distance between the two lines of action. So this will basically be equal to the force, which is 4.0 newtons, multiplied by the vertical distance or the perpendicular distance, which is equal to 0.15 meters like that. So that means my torque will just basically be equal to 0.60 newtons per meter. Newtons per meter like this. So this is my torque in this particular case. So the first thing you're supposed to take note is that we are having a couple, which means we have two forces that are similar in magnitude but acting in opposite directions. These two forces are just parallel to each other. So if we want to calculate the torque, we're going to say the magnitude of one force, since the two forces are similar, we'll just pick one. The magnitude of one force multiplied by the perpendicular distance between the two lines of action. So you're supposed to calculate the perpendicular distance between the two lines before you proceed with your calculation. And here it's simple because we're already given the directions in terms of theta. So we have 30 degrees as the directions of action between the orientation of the ruler itself and the two perpendicular forces. So that is all on this particular question. The answer is 0.6 newtons per meter. All right.